So today you are going to need a pencil, a pen if you would like, and some highlighters. You do not need the highlighters, but it is up to you. I will be using my highlighters today. So we are going to be looking at parts of a graph, okay? So first, an input-output rule takes and allows input and uses it to determine an output. Relation corresponds between the input corresponds to exactly, remember the word exactly, I capitalized it, so I think you should capitalize it, to one output. We are able to find inputs and outputs from ordered pairs, mapping diagrams, tables, and graphs. This is where we're going to be able to use our highlighters, and we're going to be highlighting. Now, it's up to you if you want to highlight. I will be. I'm going to highlight every single time I see the word input in purple. So every single time I'm just going to look around my paper and I'm going to find the word. Okay? I'm going to keep looking. Boom, I highlighted it. My next part, I'm going to highlight all the times I see the word output in pink. So again, I'm just going to look around my paper. I'm going to find all the times I see output. Awesome. So again, that's not a requirement. I think it's important to highlight sometimes. Okay, I'm going to move my paper up a little bit so we're able to see our first beautiful chunk. As you can see, this is going to be a function example. Okay, as you can see, I have ordered pairs. I have 1, 3, 2, 6, 3, 9, and 4, 12. I was gonna say 10. Oops. I'm gonna go in and I'm gonna highlight some of my inputs. My inputs are gonna be my X values. Okay, they're gonna be my X's. So I'm gonna highlight all my X values in purple. I'm gonna go and I'm gonna highlight all of my Y values in pink. It's gonna be my outputs, okay? As you can see, I was already given my information. Now I'm gonna go over here to my mapping diagram and I'm gonna write down all of my inputs, which is in purple, over here. So I'm gonna write down 1, 2, 3, and 4. Then over here, I'm gonna write down all of my outputs. These are my pinks. So I'm gonna have 3, 6, 9, and 12. Okay, I'm gonna draw arrows because it's a map. I need to figure out where my inputs relate to my output. So I can see 1 connects to 3. I see 2 connects to 4. 3 connects to 9. And 4 connects to 12. And again, I'm just gonna highlight the word input and highlight all my numbers that relate to it. And do the same thing for my output. Boop. Now we're gonna fill in our table with our numbers because we know these are all of our X values since we have X, Y. And I'm gonna put them all over here. So I should have 1, 2, 3, 4, and on my Y's I should have 3, 6, 9, and 12. Okay, again, I'm gonna highlight because I know that my inputs are gonna be my X values and my outputs are going to be my Y values. Now I'm gonna graph my beautiful equation that I have. Let's think about how is it gonna be? So I'm just going to go in and I'm going to start plotting on my points. 1, 3, 2, 6, 3, 9, and 4, 12. As I can see from this pattern, it is a function. It is continuous. Beautiful. Okay, so that is a function. Now I'm going to scroll down my paper. I'm going to look at the next example. This is not a function example. So this is something that if we see, we're going to have to know that this is not going to be a function, okay? First step, I'm going to highlight all of my inputs, and then I'm going to go in and I'm going to highlight all of my outputs, just so I know for future reference. Oop. And again, since I wrote down parentheses x, comma, y, close parentheses, I'm just going to write it down here as well so I never forget it, ever. Okay, and I'm going to put all my numbers that are my input into my box. So I have 0, 2, and 4. 2 repeats twice. I'm not going to write him twice. That's a lot of work. And then I'm going to write my outputs, my pinks. So I should have 0, 1, -2, and -3. Now again, I'm going to be drawing my arrows to point to where everything goes. So I know 0 goes with 0. I know that 2 goes with 1. I know that 2 also goes with -2. Kind of weird looking. And then I have 4 goes to -3. As you can see, it kind of looks a little weird, okay? But again, I've already stated that this is going to be not a function. So this is just an example of what we could see if it does not look like a function. Now we're going to go in and we're going to fill in our beautiful table with our points because we know our x's and our y's. So we should have 0, and then we should have 2, 2, 4 for my x values, and for my y I should have 0, 1, -2, and -3. Again, I'm going to go in and I'm going to highlight my stuff so I know for future reference. Now I'm going to plot my points, okay? I'm going to plot all the points as best as I can because again, I'm freehanding this, so I should go over 2, up 1. I'm going to go over 2, and I'm going to go down 2. Then I'm going to go to 4, and I'm going to go to 3. So I'm just going to go in, I'm going to connect all of my dots. As you can see, that is not a function. It does not look as pretty as that one. He looks kind of strange. So this is just to remember that this is not a function, okay? Awesome. Take a few seconds.